The hangar smelled of cold steel and stale fuel on a muted morning in Germany in early 1944, when a group of Luftwaffe engineers crowded around a captured American fighter that should not have survived the night. The countryside outside still whispered with the distant echoes of anti-aircraft guns. But inside the evaluation center, all attention focused on a machine nobody in the room expected to see intact: a P-47 Thunderbolt. Hours earlier, the fighter had been forced down after a running battle with German interceptors. The pilot was in custody. The aircraft was bruised, scorched, and punctured, yet strangely whole. The Germans had dragged it into the hangar before Allied fighters could swoop down and destroy it, and now, under the yellow glow of inspection lights, they were finally ready to peel it open. The men approached not with triumph but with caution. They knew the Thunderbolt's reputation, a flying hammer that refused to die. But as they unlatched the cowling, around its nose a quiet tension rolled through the room. They were about to see the heart of a machine that had become one of the Luftwaffe's most persistent nightmares. A whistle cut through the silence. Embedded inside the frame was a radial that looked less like an engine and more like a declaration. Pratt & Whitney's R2800, a 14-cylinder titan of metal and math, rested in the center like some industrial relic from a future war. It was dense, overbuilt, polished with precision welds the Germans rarely achieved in quantity. The engineers exchanged glances. This was no ordinary American power plant. Then a file folder arrived, an intelligence summary from Luftwaffe Command. Inside it, the number stood out like a cold slap. 15,000. The engineers didn't understand at first. 15,000 what? The officer clarified. 15,000 more engines exactly like this one, already built, and more being produced every single week. For the first time that morning, the hangar fell into true silence. Because in that moment, staring at the opened P-47 engine, they realized something they had never wanted to admit. They weren't just fighting Allied pilots. They were fighting an entire industrial civilization capable of replacing every loss with 10 more. And this engine, this monstrous, unstoppable R2800, was only the beginning. The Thunderbolt had not fallen easily. Even the German recovery crews said that much when they first approached the wreck in the pale light before dawn. The aircraft had gouged a violent scar through the edge of a farmer's field, torn up soil, clipped a hedgerow, and finally skidded to a grinding halt beside a cluster of pines. Yet the cockpit remained almost eerily intact, as if the machine had simply refused to die until the very last second. Luftwaffe patrols were the first to reach it. They expected to find a twisted heap of aluminum, a typical crash scene. Instead, they froze at what they saw. The wings, though riddled, with holes still held their shape. The control surfaces hadn't sheared off. Even the landing gear bays looked shockingly undamaged for a fighter that had been forced into a belly landing. And the armored cockpit enclosure, the very chamber that had protected countless American pilots, had become a capsule of survival. The pilot inside was battered, dazed, and bleeding, but alive. Within minutes, the Germans radioed for a technical recovery team, not because they needed scrap, but because a nearly intact P-47 was a rare prize. The Luftwaffe's evaluation centers, from Rechlin to the secret testing hangars scattered across the Reich, were always desperate for Allied planes they could study firsthand. Manuals captured from dead pilots told part of the story. Debris fields told another. But nothing compared to a real fighter mostly intact sitting right there in the mud. By the time the engineers arrived, villagers were gathering. Some touched the metal skin with awe. Others muttered curses. They had seen what these machines did to German supply columns. The recovery crew knew they had minutes, maybe less, before Allied fighters returned to finish the job. P-47 seconds were notorious for circling back over their fallen comrades. They guarded their pilots like wolves guarding a wounded packmate. So the Germans rushed. Metal clamps, tow cables, a half-track roaring. The Thunderbolt groaned but held together as they dragged it onto a makeshift road, then onto a transport truck headed toward the Luftwaffe's evaluation facility. Every man involved knew the risk American fighters could appear without warning, but luck favored them that morning. The sky stayed empty, and by sunrise, the P-47 was safely behind German lines. Inside the hangar later that afternoon, with the aircraft raised on jacks and its belly cleaned of dirt, the real work began. Engineers circled it like archaeologists around a newly unearthed relic. They tapped the armor plating with knuckles, lifted panels peered into. Hydraulic systems marveled at wiring looms arranged with almost obsessive order. But nothing impressed them more than the evidence written directly into the aircraft's wounds. Bullet holes that should have severed systems somehow hadn't. Hydraulic lines were doubled, control linkages were triple-backed. Components were arranged so even catastrophic damage could be bypassed by redundant pathways. One German technician muttered what the others were already thinking. This isn't a fighter. It's a fortress. But as they would soon discover, the airframe, impressive as it was, wasn't the thing that made this aircraft dangerous. The real shock waited under the cowling. The first sound inside the hangar that evening was the slow, deliberate clack of metal latches being undone. The Germans gathered around the Thunderbolt's nose tools in hand, their breath rising faintly in the cold air. They had examined Allied radials before the Wright R-1820, the Pratt & Whitney R-1830 decent, engines well built, but nothing beyond the reach of German craftsmanship. So when they unfastened the P-47's cowling, most expected to see something familiar. They did not. The moment the final cowling segment dropped away, a quiet gasp rippled through the group. It sat there like a mechanical monolith. The Pratt & Whitney R-2800, double wasp 14 cylinders, arranged in two perfect rows, a dense halo of steel and aluminum, built with a level of precision that made even seasoned German engineers hesitate. What struck them first was the sheer mass of it. The R-2800 looked overbuilt to the point of absurdity, like something forged for a battleship rather than a single-seat fighter. Every cylinder head was machined to tight tolerances. The cooling fins were intricate, almost crystalline. The ignition harness was polished, sealed from moisture and heat. The Germans leaned in closer. The wiring wasn't just functional, it was elegant. Then came the realization that stopped them cold. The metallurgy. One officer ran a gloved hand along the casting of a cylinder barrel and muttered the German equivalent of DMN. The steel alloys used in the American engine were beyond what most factories in the Reich could produce at scale, especially in 1944. These metals required chromium, molybdenum, nickel materials. Germany lacked in abundance. Even worse, the casting quality showed almost no voids, no impurities, no shortcuts. Every piece looked like it had come from a factory that treated mass production like an art. Next, they studied the heart of the system, the turbo supercharger. The Germans had heard rumors. They had seen the exhaust trails of Thunderbolts climbing at altitudes where Luftwaffe radials gasped for oxygen. But seeing the actual machine, a labyrinth of ducts, pipes, and heat-resistant alloys, was different. This wasn't improvisation. It was infrastructure, a weapon built on the assumption that America would fight wars above 20,000 feet and win them, through engineering supremacy. A senior engineer compared it reluctantly to their own prized design, the BMW 801, used in the Focke-Wulf 190. The BMW 801 was a capable engine but temperamental, with finicky cooling systems, complex controls, and a reputation for overheating if not flown precisely. It was an engine that demanded expert attention. The R-2800, by contrast, looked like it demanded only fuel air and a pilot willing to push the throttle forward until the world blurred. One German wrote in his evaluation notes, translated decades later, "It appears the Americans designed this engine to be impossible to break, and if broken, to be replaced in hours. They had no idea how right they were." But the true shock had yet to come. As they continued their inspection, an adjutant walked briskly into the hangar, holding a thin folder marked with Luftwaffe intelligence stamps. He handed it to the lead engineer, who opened it with mild annoyance. Paperwork always arrived at the worst time. The annoyance didn't last long, because inside that folder was a number so large, it seemed like fiction. And once they understood what it meant, their faces changed. The lead engineer stared at the page for several seconds before speaking. At first, the others thought he was reading it wrong. He adjusted his glasses, looked again, then slowly exhaled a long, defeated breath that carried across the hangar louder than any shout. The adjutant repeated the message, as if forcing the words into the room made them any easier to accept. 15,000. Already completed. The folder explained everything in cold, bureaucratic language. American war production records gathered from intercepted radio traffic, captured documents, and intelligence from neutral countries showed that the United States had surpassed every expectation. Their factories had already built more than 15,000 2,800 engines, with additional lines expanding output even further. The Germans stood frozen tools, dangling from their hands. 15,000 engines meant 15,000 fighters, 15,000 attackers, 15,000 birds of prey that could climb higher, dive faster, and absorb more punishment than anything Germany could put into the sky in those late months of the war. One mechanic whispered, 15,000 is impossible. Another corrected him, voice almost hollow, not for them. A sense of unease filled the air, not shock anymore, but something heavier. Because the Germans knew their own numbers. They knew what their factories could produce on their best days, and how few of those best days remained. They also knew what Allied bombing was doing to their industrial sector. Buildings shook nightly, trains vanished under clouds of fire. Skilled workers were gone, drafted, relocated, or lost to the chaos of war. Raw materials were scarce. Fuel was scarcer. The Germans in that hangar suddenly understood something devastating. Even if they built a perfect engine, they couldn't build enough of them. Even if they trained the perfect pilot, he'd face 5 replacements for every one he downed. Even if they destroyed a Thunderbolt, America wouldn't care. The lead engineer closed the folder and placed it on a workbench beside the exposed R2800. The number sat there like a verdict, 15,000. The Luftwaffe officers exchanged looks not of anger but of realization. They had spent years believing the war in the air could still be won with superior skill or breakthrough technology. But this number, this simple, brutal number, told a different truth. The war was shifting. It was no longer about brilliance or daring. It was about output, capacity, replacement. They turned back to the engine, suddenly aware that they weren't studying a single captured machine. They were staring at the representative of an entire army of engines, an industrial swarm Germany could never hope to match. One officer muttered a final, almost resigned thought. This engine is not our problem. The other 15,000 are. And now they needed to understand the aircraft built around this mechanical beast. Because if this engine alone was frightening, the plane carrying it was something else entirely. The Germans returned to the Thunderbolt the next morning with a new level of urgency. Understanding the engine was one thing, but understanding the aircraft built around it was now a matter of survival. Every bolt, every panel, every rivet suddenly felt like a clue to a larger mystery. How had America turned this oversized brute into one of the deadliest machines in the sky? The first thing they noticed was the sheer physical presence of the P-47. It wasn't elegant like a Messerschmitt. It wasn't sleek like a Focke-Wulf. It was a wall of metal shaped into a fighter. Standing beside it felt less like standing next to an airplane and more like standing next to a piece of industrial machinery that had somehow grown wings. German test pilots, assigned to evaluate captured Allied aircraft, often joked that the Thunderbolt looked like it had been designed by someone who hated aerodynamics. But the longer they studied it, the more that joke faded. Because the P-47 wasn't built to dance, it was built to endure, to strike, to carry heavy loads, soak up punishment, and return home when everything else would have been falling out of the sky. They mapped the internal structure and were stunned to see how many systems had built-in redundancy. Hydraulic lines had backups, electrical circuits had alternates, ammo feeds were reinforced. The fuel tanks were heavily self-sealing, wrapped in thick protective layers that resisted both heat and punctures. Even the cockpit was a reinforced capsule, a metal bunker wrapped in curved plexiglass. A German engineer tapped one armored plate, listening to the sound resonate through the fuselage. "No wonder they survive everything we throw at them," he muttered. Then came the weapons, 8 50 caliber, machine guns, 4 in each wing. To a Luftwaffe officer, accustomed to the lighter armament of most German fighters, this felt absurd, like a flying anti-aircraft battery disguised as a single-seat fighter. 8 guns meant incredible fire density. 8 guns meant a short burst could shred a locomotive, pulverize a truck convoy, or tear a fighter apart before the pilot even realized he was being fired on. And then they studied the dive performance. The Thunderbolt had an unnerving, almost unnatural ability to fall through the sky faster than anything the Germans had. Test records from their own captured trials confirmed what pilots at the front had been complaining about for months. Once a P-47 pointed its nose down, nothing could stay with it. The airflow compressibility issues that plagued many fighters seemed to affect the Thunderbolt far less. It could escape. It could chase. It could use gravity as a weapon. One test pilot wrote in a report, "Fighting a P-47 inches, the vertical is like fighting a stone dropped from heaven." But the most unsettling discovery came when they examined the aircraft's layout for maintenance. Panels removed quickly, components swapped fast. Everything was structured so that factory workers, even newly trained ones, could assemble, repair, or replace parts in minimal time. It was not the design of an artisanal machine. It was the design of an industrial product. A product meant to be built again and again and again in quantities Germany couldn't match even in its best years. The Germans stepped back from the Thunderbolt with a sense of growing dread. They understood now that this plane wasn't an anomaly. It wasn't a rare masterpiece. It was a blueprint meant for mass replication, powered by an engine that could push a machine this large to fighter speeds, loaded with firepower, heavy enough for a bomber wrapped in armor, thick enough for self-preservation. And the Americans weren't building hundreds of them. They were building thousands. But the Germans were about to learn something worse, much worse. The P-47 wasn't just backed by a powerful engine and clever design. It was backed by a national industrial machine that ran day and night and never stopped. A cold realization settled over those German engineers as they looked again at the R-2800 engine on the workbench. It wasn't just a marvel of engineering, it was the product of a wartime machine that never stopped running. To open one engine and find 15,000 more waiting meant nothing without understanding how America was building them so relentlessly. A few days after the engine teardown, Luftwaffe intelligence compiled a detailed report on American production lines. The R-2800 wasn't crafted in a single plant, it was made in dozens scattered across the United States. Pratt & Whitney in East Hartford, Connecticut was the heart, but subsidiary plants, subcontractors and licensees stretched the web far and wide. Buick, Chevrolet, Ford and Nash all manufactured R-2800 seconds under license. Fraser +2 Warbird Sound Air Shows. .com +2. The Ford plant at Dearborn once, a car factory pivoted entirely to war. By 1944, its Willow Run facility had been transformed into a high-volume engine production line. Assembly scenes looked more like an automotive plant than a fighter engine hub. Massachusetts Institute of Technology. Subcontracting wasn't second tier. It was central to the strategy. Rather than rely solely on Pratt & Whitney, the U.S. spread engine manufacturing across multiple companies so that any one factory could fail without crippling the whole system. Penelope, meanwhile, Nash Kelvinator's Kenosha, Wisconsin plant churned out R-2800 seconds at a relentless rate. According to wartime production records, more than 17000 R-2800 units were built there, with peak employment in the thousands. Warbirdsandairshows.com. That kind of workforce, women, first-time machinists, men drawn from the civilian workforce, reflected how deeply the war economy touched American life. Fraser. It wasn't just about labor. Tooling, machining materials, everything was scaled up. Pratt & Whitney and its partners innovated in forging and casting, crafting the cooling fins, crankshafts, and supercharger parts with astonishing speed. Machine design. The Double Wasp's unique design, with its 18 cylinders and supercharged system, demanded precision, yet the U.S. factories churned them out by the thousands. What deeply unnerved German engineers wasn't just the number of engines, it was the redundancy in American production. If one plant was hit by bombing, there were others. If there was a labor strike or material shortage, the engine lines could shift between manufacturers. Armstrong's old observation about total war felt all too real. And the manpower. At its peak in early 1944, some 340,000 workers were employed in U.S. aircraft engine plants, Fraser. Many were new to manufacturing. They were trained, organized, and sent into the engine factories with the purpose of building hundreds, sometimes thousands, of complex radials every month. The German engineer who inspected the documents shook his head. He realized, even if they destroyed every captured Thunderbolt, even if they broke every R2800, they found they could never outproduce this army. In that hangar, surrounded by riveted sheet metal and engine parts, fear flickered in the engineer's eyes. The Americans weren't just fielding a powerful aircraft, they were wielding a nation's industrial capacity as a weapon. And the R2800 on the bench was its beating heart. The Luftwaffe didn't stop at inspection. Once the Thunderbolt was patched up enough to fly, the engineers handed it over to the test pilots, men who lived on the razor's edge of danger, flying captured enemy aircraft to understand their limits. Many of them had survived the Eastern Front. Some had flown everything from a Bf-109 to a Yak-9, but none had ever flown anything quite like a P-47. The morning of the test flight was cold, with thick clouds hanging low over the evaluation field. The P-47 sat on the runway like a steel giant, patched, refueled, armed only with its data recorders. Its engine warmed with a deep rolling growl that didn't whine or buzz the way German radials did. Instead, the R2800 vibrated the air around the plane like the ground itself was reacting. The pilot climbed the ladder and paused, placing a hand on the armored cockpit rim. He later admitted it felt less like climbing into a fighter and more like entering a machine built to survive the apocalypse. He strapped in. He primed the engine. He pushed the starter. The R2800 ignited with a thunderous burst, coughing smoke, then settling into a smooth, menacing rhythm. Ground crew stared. Even idling the engine pulsed like a massive industrial pump tied directly into the earth. The pilot adjusted his headset and throttled forward. The Thunderbolt began to roll. 30 meters, 50 meters, 100 meters. Then the test pilot said something no German engineer expected to hear. "It's accelerating too fast." He pushed the throttle further. The P-47 leapt. Not climbed, leapt into the sky with a power-to-weight ratio the Germans had never witnessed in such a heavy aircraft. The R2800 hurled the machine upward like a slingshot. Even the famously powerful BMW 801 of the Focke-Wulf couldn't match this sensation. The test pilot banked, rolled, pushed the nose down, pulled it up again. The controls were heavy but predictable, like lifting a heavy door built on perfect hinges. Every movement was stable. Every response was smooth. When he leveled out above the clouds, he ran the engine through its high-altitude regime. That's when he saw it. The manifold pressure didn't drop. At 20,000 feet, the R2800 behaved as if it were still breathing sea-level air. The turbo-supercharger roared to life, feeding compressed oxygen into the cylinders with mechanical confidence. German engines at that height gasped and wheezed, losing power. The R2800, by contrast, simply kept climbing. The pilot pushed further. 25,000, 28,000. Just shy of 30,000 feet, the Thunderbolt still had thrust in reserve. When he leveled out, he murmured a sentence, the engineers documented word for word. "This aircraft does not fight the air. It dominates it." Then came the dive test. He pointed the nose down, throttled back, and let gravity take over. The Thunderbolt plunged. Faster, faster still. The altitude spun past 20,000, then 15, then 10. The P-47 gathered speed at a rate that made the pilot's stomach press into the harness. German fighters hit compressibility and shook violently in dives this steep. The Thunderbolt? It held firm. It cut through the air like a falling anvil stable and obedient even near the edge of control. The pilot pulled out of the dive cleanly, a maneuver that would have destroyed a Bf-109 at that speed. He returned to base shaken not because the aircraft was dangerous, but because it was fearlessly capable. When the Thunderbolt rolled to a stop and he climbed down the ladder, the engineers crowded around him. He took off his gloves. He removed his helmet slowly. Then he spoke the words that would become infamous in the test report. If they can build thousands of these, the war in the air is already over. The hangar fell silent, because deep down every man there knew he was right. The P-47 wasn't just strong, it wasn't just fast, it wasn't just survivable, it was repeatable. And repeatability in 1944 was the one thing Germany no longer had. The last German intelligence packets that mentioned the P-47 came in the final months of 1944. By then, the Reich's fighter arm was collapsing, oil supplies were strangled to a drip, and new pilots were dying faster than they could be trained. But buried inside those late-war memos was one final haunting line, a line written by an engineer who had studied wreckage, captured manuals and interviews with pilots who had survived encounters with the Thunderbolt. He wrote, "This aircraft is not simply a machine. It is a factory's promise." It was a quiet admission of something Germany could no longer deny. The power inside the P-47, the R-2800, was more than an engine. It was a symbol of an entire industrial reality that the Reich could not match. Every time German engineers inspected a recovered Thunderbolt engine, they found the same thing: quality, predictability, interchangeability, and the unmistakable signature of a nation that had planned for a long war. But that wasn't the whole story. The final surprise came when German technicians reviewed R-2800 test logs taken from captured Allied bases. They didn't understand the numbers at first. They thought they were misprints. The engines logged hundreds of flight hours, then were pulled, inspected, cleaned, and put back into service again. The wear rates were so low that German analysts assumed the Americans had added a zero by mistake. And then one report from an American depot confirmed it. A senior NCO wrote, "Engines swapped this week, all performed within tolerance. Next batch ready for installation, next batch." That was the phrase that haunted them. Because behind every R-2800 tearing across the sky, there were thousands more waiting, finished, tested, and ready to ship. 15,000 units of one engine family alone, with more coming every week. The sheer industrial gravity of that number was beyond anything Germany could counter. But this final section isn't just a comparison of factories. It's the moment when the Luftwaffe understood that no matter how talented their designers were, no matter how advanced their jets became, the war had slipped out of reach. An aircraft like the P-47 was more than a machine of aluminum and steel. It was the physical expression of a nation that had prepared for total victory before the first shot was fired. And in the winter of 1944, as Allied aircraft blotted out the sky, German commanders realized something else, something far more painful. The Thunderbolt didn't win because it was indestructible. It didn't win because its engine was unstoppable. It won because every time one fell from the sky, another one rose to replace it, and another, and another. An endless line stretching far beyond any horizon Germany could imagine. Back in that quiet hangar in early 1944, German engineers stepped away from the open R-2800 engine with a dawning, painful understanding. This was no mere machine. It was a symbol, a testament to a nation's ability to wage war, not just with bullets and bombs, but with factories and assembly lines. The P-47 Thunderbolt wasn't the fastest or most agile fighter in the sky. It wasn't a sleek ace built for dogfights. It was something else entirely. A flying fortress, powered by an engine that was overbuilt, oversized and engineered for relentless, unyielding production. An engine that represented not just power but endurance, endurance of supply chains, manufacturing, and manpower. Germany had faced countless technological challenges during the war, but none matched the scale of America's industrial might embodied in that single R2800 engine and the thousands more like it waiting quietly behind the scenes. In the end, the war in the air was less about the skill of a single pilot or the cleverness of a new design. It was about something far more brutal, the grinding, overwhelming ability to replace what was lost faster than it could be destroyed. The P-47 was a weapon forged from steel and production quotas, precision and logistics. It was a flying declaration that in this war, victory belonged to those who could build not just machines, but machines by the tens of thousands. And the Germans, staring at that engine in 1944, understood it was a battle they could no longer win.